Good morning and welcome to today's class. Today's class is a continuation of our previous classes on trigonometry. In today's class, we shall be solving exercises on complementary angles. At the introductory class, I did explain to us the concept of complementary angle, where I said two angles are said to be complementary in a right angle triangle if their sum total gives you 90 degrees. I was able to demonstrate that using a right angle triangle, where I gave an illustration of triangle ABC, where we said angle C is said to be theta degrees. That automatically means that angle A is equal to 90 minus theta. For triangle ABC being a right angle triangle, if angle B is already in 90 degrees, it therefore means that the sum of angle C and angle A will give us 90 degrees. And we said if angle C is theta, definitely angle A is said to be 90 minus theta. From that class, we are able to establish that cos theta is equal to sine 90 minus theta, whereas sine theta is also equal to cos 90 minus theta. With this knowledge, we shall be using this in solving problems on trigonometry. In question 1, we are asked to solve the equation that if cos A is equal to sine 56.3, what is A? Using the trig identity, we have already established that cos A is given to be equal to sine 90 minus A degrees. And if we call this equation 1 and call this equation 2, equation 1 is stating that cos A is equal to sine 56.3, and cos B is saying cos A is equal to sine 90 minus A. That means that equation 1 is equal to equation 2. And if that being the case, we can then say that sine 56.3 is equal to sine 90 minus A, since both are said to be equal to cos A. So when you simplify, if sine 56.3 is equal to sine 90 minus A, that definitely means that 56.3 is equal to 90 degrees minus A. So for us to get our value for A, we are going to make A the subject of the formula. And this gives us, if you take minus A to the other side of the equation, you now have A to be equal to 90 minus 56.3 degrees. And when you subtract, A is equal to 33.7 degrees. That is our answer. Kindly like our videos while you watch, while we encourage you to subscribe to our channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. You can also follow us on Facebook at My Lesson Teacher Maths or on TikTok at My Lesson Teacher. Question 2 says, if sine 19.35 degrees is equal to cos 2 theta, what is theta? Also, with our trig identities from complementary angles, we can also establish that since cos theta is equal to sine 90 minus theta, it therefore means that cos 2 theta will also be equal to sine 90 minus 2 theta. If sine 19.35 degrees is equal to cos 2 theta, call this equation 1, and cos 2 theta is equal to sine 90 minus 2 theta, it therefore means that sine 19.35 degrees is equal to sine 90 minus 2 theta. Then we simplify. That means that 19.35 degrees is equal to 90 minus 2 theta when you compare. So making 2 theta the subject of the formula by adding 2 theta to both sides of the equation, as well as subtracting 19.35 from both sides of the equation, you have 2 theta to be equal to 90 minus 19.35 degrees. Now you simplify, we have 2 theta to be equal to 90 degrees minus 19.35 degrees gives us 70.65 degrees. Now dividing both sides by 2, you have value for theta to be equal to 70.65 degrees divided by 2. And when you divide both sides by 2, you have theta to be equal to 35.325 degrees. And this is your answer. In this exercise, we are asked to solve the equation that sine 11.4 degrees is equal to cos theta. What is theta? All you need to do is just to use the trig identity, which I have shown you from the complementary angles, and compare it with this. Thereafter, you can then simplify and solve, get your solution. That is to say that if cos theta is equal to sine into bracket 90 minus theta, which is one of the trig identity, since cos theta is equal to sine 11.4 degrees and that same cos theta is equal to this, you can then equate sine 11.4 with sine 90 minus theta, since both of them are equal to cos theta, so that this becomes sine 11.4 degrees is equal to sine 90 minus theta. Now, by comparison, you have it that 11.4 degrees is equal to 90 minus theta. Making theta the subject of the formula, you have theta to be equal to 90 degrees minus 11.4 degrees. And theta is equal to 78.6 degrees. In question 4, we have it that cos x is equal to sine 63 degrees. We should find the value of x. Now this implies that since we have it that cos x is also equal to sine 90 minus x degrees from our complementary angles, we can therefore say that sine 63 degrees is equal to sine 90 minus x. And if that being the case, by comparing the angles, you have it at 63 degrees definitely will be equal to 90 minus x. Then you make x the subject of the formula, and that gives you your answer. That is, x now will be equal to 90 minus 63 degrees. So 90 degrees minus 63 degrees is said to be equal to 27 degrees. Question 5, we have it that if sine 79.5 degrees is equal to cos 2x, we should find the value of x. This implies that cos 2x will be equal to sine 90 minus 2x. Comparing equation 1 and 2, you agree with me that sine 79.5 is equal to sine 90 minus 2x. So when you compare the angles, this becomes 79.5 degrees is equal to 90 degrees minus 2x. You then solve for x by making 2x the subject of the formula and moving it to the left hand side. You have 2x to be equal to 90 minus 79.5 degrees. When you simplify, this becomes 2x is equal to 90 minus 79.5 degrees is said to be equal to 10.5 degrees. And when you divide both sides by 2, you have it that x is equal to 5.25 degrees. And this is your answer. Question 6. We are asked to solve the equation cos theta is equal to sin theta plus 30 degrees. You are asked to find the value of theta, that when you find the cos of it is equal to the sine of that theta plus 30 degrees. So we still go with the idea we got from the complementary angle, that cos theta is same to be equal to sine 90 minus theta. And if cos theta is equal to this equation in equation 1 and is same equal to this in equation 2, we can then equate equation 1 and 2 together. That is to say that sine theta plus 30 degrees is equal to sine 90 minus theta. By comparing the angles, you have it that theta plus 30 degrees is equal to 90 minus theta. Collecting like terms, by adding theta to both sides and subtracting 30 to both sides, you have it that theta plus theta will be equal to 90 degrees minus 30 degrees. That is, when you simplify, you have 2 theta to be equal to 90 degrees minus 30 degrees is equal to 60 degrees. Dividing both sides by 2, you have it that our angle theta is equal to 30 degrees. Such that if you now substitute it in this equation from the original question, you have it that cos 30 degrees, which is our value for theta, will be equal to sine 30 plus 30. And sine 30 plus 30 is said to be what? Sine 60 degrees. So these two are said to be complementary angles. And if you punch your calculator or you use your trig table, you will agree with me that cos 30 degrees is equal to sine 60 degrees. Question 7, we are asked to solve the equation where cos 2 theta is equal to sine into brackets theta plus 10 degrees. Go ahead with the trig identity you have from the complementary angles that says cos 2 theta will be equal to sine 90 minus 2 theta. So if this being the case, equation 1 and equation 2, they are said to be equal, then you can equate both of them together by saying sine theta plus 10 degrees is equal to sine 90 minus 2 theta. And by comparing the angles, we have it that theta plus 10 degrees is equal to 90 minus 2 theta. When you collect like terms, this becomes theta plus 2 theta is equal to 90 minus 10 degrees. And theta plus 2 theta gives us 3 theta to be equal to 90 minus 10 is said to be 80 degrees. Now, divide both sides by 3 to get your value for theta. And our answer is theta is said to be 80 divided by 3. When you punch your calculator, it gives you 26.67 degrees approximately. When you approximate it, this is the value for your answer. When you substitute the value back into the original question, you agree with me that sine 2 theta will be equal to sine theta plus 10 degrees. Question 8, that we should solve sine 3 theta being equal to cos theta minus 60 degrees. We also have it that sine 3 theta is equal to cos 90 minus 3 theta according to our complementary angles. And if equation 1 and equation 2 are equal, equate both of them together. You have cos theta minus 60 degrees to be equal to cos 90 minus 3 theta. We then compare the angles. That is to say that theta minus 60 degrees is equal to 90 degrees minus 3 theta. When you collect like terms, this becomes theta plus 3 theta is equal to 90 degrees plus 60 degrees. This becomes 4 theta to be equal to 150 degrees. Dividing both sides by 4 gives us our value for theta, and theta is equal to 150 divided by 4 is said to be 37.5 degrees. And this is our answer. The next question, question 9, says we should solve the equation sine 3 theta plus 30 being equal to cos 4 theta. So this can be simplified to be cos 4 theta, we said from our complementary angles, is equal to sine 90 degrees minus 4 theta. So equating equation 1 and 2, this becomes sine 3 theta plus 30 degrees is equal to sine 90 degrees minus 4 theta. And when you compare the angles together, this becomes 3 theta plus 30 degrees is equal to 90 degrees minus 4 theta. And when you make theta the subject of the formula, by collecting like terms, you have it that 3 theta plus 4 theta will be equal to 90 degrees minus 30 degrees. And when you simplify, this gives us 7 theta to be equal to 90 minus 30 is 60 degrees. And when you divide both sides by 7 to get your value of theta, and 60 divided by 7 is said to be 8.57 degrees. When you use your calculator, you can confirm this. Our last exercise on this topic says we should solve the equation that if sine 3 theta is equal to cos 4 theta, what is the value of theta? You also apply same. If sine 3 theta is equal to cos 90 minus 3 theta, which is identity for complementary angles, you then have it that cos 4 theta is equal to cos 90 minus 3 theta. When you equate equation 1 and 2, by comparing the angles, you then have it that 4 theta will be equal to 90 minus 3 theta. And when you collect like terms, you have it that 4 theta plus 3 theta is equal to 90 degrees. This gives us 7 theta to be equal to 90 degrees. What is the value of theta? Divide both sides by 7, and that gives you your value for theta. And our answer theta is said to be equal to 12.86 degrees. So this is our answer. Now when you substitute 12.86 for theta in this equation, it makes what you have on the left hand side to be equal to what you have on the right hand side when you punch your calculator. That brings us to the end of today's class. In today's class, we have seen how we can apply the use of complementary angles in solving trig ratios. Kindly like our videos as you watch, while we encourage you to subscribe to our channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. We also recommend that you share the link with your friends and families so that they can also benefit from this class. You can interact with us using the comments section. You can also follow us on our social media on Facebook at My Lesson Teacher Maths and also on TikTok at My Lesson Teacher. I appreciate you for staying to the end of this class. See you in our next class where we shall be taking more exercises on complementary angle. Bye and do have a nice day.